Hello everyone, we will be starting with the session now. Dear authors and invited guests, welcome to technical session 3A. My name is Dimahi Patel and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event will be held tomorrow in Bangkok, and the virtual event is being held through Zoom from 9th to 11th April 2026. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes per presentation and 2 minutes per question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Now, before we start with the presentations, I would like to introduce you all to the chair of the session. We have with us Dr. Ashavari Das. Dr. Ashavari is a lecturer at the Higher College of Technology at HCT Dubai, UAE, with over 18 years of experience in academia and media. Her work focuses on communication technologies and their social impact, with research interest in healthcare information seeking behaviors, digital literacy, and creative technologies, along with gender and social media and communication policies, emphasizing inclusive and informed digital engagement. A warm welcome to you, ma'am, and I request you to share a few words with the presenters today.
All right. Thank you so much, Dhimahi. First of all, I really like your name. And I think it is something to do with the Sanskrit shloka. But anyways, all right. I'm very happy, guys. I think Dhimahi has already introduced me, but I'm delighted to actually share this session with all of you. I am actually speaking from Dubai. And I don't know if my video is on. So, actually, I'm very excited to hear all of you speaking today because I'm going to bring in my social scientist sort of an expertise to this panel. I'm not at all a technical person, so when I was going through your paper titles, it was they were Greek to me. But I will definitely try to bring in a more critical communication perspective. So my questions will be slightly different than what you would probably expect, and I'm hoping that Dr. Vivek will pitch in for the technical parts, but I would be more interested in like what you found, how you framed the problem, who you included, who you excluded, things of that nature. What happens when these technologies kind of enter messy human contexts and things of that nature. So they will perhaps not be what you expect, but as a social scientist, I have worked with engineers and health scientists, so I believe that we can have a very interdisciplinary approach towards academia. So I will bring in that, and I personally feel that presenting is a very vulnerable activity, so we really need to have a very safe space. Our questions will not be judgments, and I'm hoping that we will find it very safe to share our feelings here and our findings, right? So without further ado, Dhimahi, if you want to take over and continue, we'll be happy to start.
Yes, ma'am. Thank you so much. We also have with us Dr. Vivek Devidas Patil to chair our session. Dr. Vivek Patil is an assistant professor at the Vishwakarma Institute of Information Technology in Pune, India, and his research focuses on artificial intelligence, machine learning, and development of assistive technologies for special education. He is actively involved in teaching, research, and academic development in model computing domains. I welcome you, sir, and please share any introductory remark for the presenters today.
Yes, thank you, Dimai, and nice to see you here. Right? I hope I'm clearly audible. Yes.
Yes, sir.
Yes, thank you. So, good afternoon, everyone. So, it's really an honor to serve as a session chair for this particular session, right? And I went through the all the titles as we have an excellent set of presentation today. I encourage all the presenters to share their ideas confidently, and I also invite the participant to actively engage with the question and constructive feedback, right? So thank you, everyone. Thank you, Dimai. So let us begin with the session, if you allow, right? Make it productive and insightful for all. Thank you very much.
Yes, thank you, sir. We will be starting with the presentations now. First up, I would like to call MV Parth to present his study on a hierarchical deep learning framework for ciphertext-only classification of cryptographic algorithms.
Thank you,
MV
Dimai.
Parth. Yes,
Uh,
sir.
um, yes. Thank you, Deemani. I'll try presenting. Please let me know if there are any. Uh, can you guys able to view my presentation?
Yes, sir.
Okay. Good afternoon, Jury. This is Parth. I'm from TS University. I'm in my final year BTech, pursuing computer science engineering. And this is my final year project titled A Hierarchical Deep Learning Framework for Ciphertext Only Classification for Cryptographic Algorithms. This is a group project. I have four teammates. I have three other teammates, Haripriya, Ritija, and Skandan, guided by our professor, Dr. Manju. So I would like you to go through I would like to present the
Excuse me,
problem
sir.
statement. Hello,
Your
yes.
PPT screen is not visible to us. Huh, okay. Please continue.
Okay. I think the presentation mode is not working, so let me just do it through the Canva itself, if that is okay with the jury.
Yes, sir.
Okay.
Yes, please.
Okay. So the problem statement in this digital forensic and cybersecurity, identifying cryptographic algorithms from plain text is quite challenging and quite important, especially in scenarios where neither the plain text or the encryption keys are available. Now, you might ask, why do we require to find the cryptographic algorithm? In the process of cryptanalysis or whenever we are trying to work with uh, encrypted data, which is most of the time nowadays, because there's a lot of data online and all of them had to be in a secure place. So encryption comes everywhere. And when there is data, there are those who are trying to hinder the data, handle the data. At that point, the process of cryptanalysis and cybersecurity comes in handy. So the first step in handling encrypted data is to identify which algorithm it's been used uh, to encrypt that particular plain text, right? So that is where our project would come in handy. For example, let me give you an example, a scenario. You are a high tech, high availability data a data fintech company, and then some ransomware pirates have encrypted all of your files, and they are demanding certain amount of ransom for you to give so that they would give the key. So rather than giving away the ransom, what you could try to do is decrypt the data if possible. Get to know which algorithm they have used to decrypt the data. For that, this project of ours comes in handy because we are able to identify which encryption algorithm was used to encrypt the data very quickly. So that was our problem statement. Now, the existing research domain is very limited in the scope, where we are trying to use AI and ML and deep learning algorithms to uh, identify the encryption algorithms. They are mostly focused on identifying one or two algorithms like AES or triple DES. But what we are trying to do is we have multi-class classification. That means uh, we are trying to we are trying to identify six different types of algorithms: AES, triple DES, Blowfish, RSA, Elgamal, and SHA, spanning across symmetric and asymmetric algorithms. And let me tell you
Hello.
the research we have done. Hello, yes.
Parth, your screen is not visible.
Oh, uh, is it visible now?
We can
Yes.
see your abstract and scope screen.
Yes.
The title.
Okay, okay. Abstract and scope. Mm, yes. So coming back, the previous work is limited uh, very much on only the symmetric algorithms, but we have also tried to identify the asymmetric and hashing algorithms like SHA-256, which is used mostly in a lot of banking sectors. So this is the architecture of our project. We have synthesized our own data set. We thought we wouldn't be able to, with our research, we concluded that we wouldn't be able to get a huge and vast data set comprising all of the algorithms mentioned. So what we did is we open sourced an email corpus that was there in Hugging Face from the company Enron. And then we encrypted all the email corpus. First, we broke them into different bite-sized samples, and then we encrypted them using all the six algorithms. That made our data set. And then in that data set, we ran uh, feed forward, we ran feature extraction, where we were trying to extract like each encryption ciphertext has its own feature, right? A signature feature. Those features we were trying to extract so that we can identify which algorithm was used to encrypt it. In that case, we tried to extract the statistical and TF-IDF features. These features were able to tell us exactly the signature of that algorithm used to encrypt it. Like let's say AES or triple AES has a different signature. It has less randomness compared to Algamal and vice versa. So such properties which act as signature for each algorithm, we were trying to extract those features. And after extracting all those features, we tried to train our model. We used a deep learning model called deep feed-forward neural network. And since we are using two different hierarchies, we can say it as a uh, deep neural network model. There are this is a two-stage hierarchical architecture. Why? Because the first stage of neural network helps us to identify uh, is basically trained on identifying which family of the encryption algorithm was used to encrypt. It could be symmetric, asymmetric, or hash. Now, and then the second stage tells us exactly which algorithm was used to encrypt the plain text. So, why two different hierarchical architecture, you may ask? The purpose is to reduce the confusion in the early on stages itself, because we were facing a lot of difficulty trying to get the enough desired accuracy to just a single feed-forward neural network layer. Now, these are some training details, which is more niche, and I would like to explain at the end when there is more time. And our baseline was on random forest. Like this is a machine learning model used to identify, like we used random forest instead of feed forward neural networks to identify. The accuracy was 78%, and macro F1 score, that is the average F1 score, was also the same. The observation was random forest was able to capture the global patterns but was failing in the fine-grained sequential dependency. So that is when we realized we should go further more and have a model that has multi-layers so that we can capture the more detail in between the lines, uh, details of the ciphertext. And these are our results. We achieved a test accuracy of 82.37% with a average F1 score of 0.8159. This
Excuse me, sir.
this
Gentle
huh,
reminder that you've crossed 9 minutes.
okay, sure. Uh, yes, we also noticed that identifying symmetric ciphertext was more difficult and had like a lower percentage of accuracy because of the randomness similarities between them. And this could have been the project UI. And coming to limitations, we have seen that the architecture is faltering when it comes to symmetric algorithms, like we had mentioned, and it is not able to, and its accuracy even decreases a little bit when it comes to the smaller byte size that we will have to work on. And then future work is we are just right now trying to detect which cipher algorithm was used to encrypt it. It would have been better if, like, in future work, if we could identify the key also which was being encrypted, which was being used to encrypt the ciphertext. That would have been, but then the scope of our research was limited since this is just a BTech college. And yes, conclusion is we were able to design a very good, a standard and a fast uh, machine learning model, deep learning model, which could identify the algorithm used to encrypt a particular ciphertext. Thank you. Uh,
Ashavari ma'am, any questions for him?
I will, but I will ask Dr. Vivek, please check your message. I think he should get priority since he's into the technical aspects. But let me ask Dr. Vivek. Do you have any questions, Dr. Vivek?
Yes, I have few questions. So
Please
far,
take
yes,
priority in
and
all the
yes.
presentations because I'll ask the social impact questions, but after you go.
Yes, totally understood. So Parth, can you summarize the key novelty or what is the main contribution of your work?
okay, my main contribution of the work is creating the data set and coming up with the idea of having a hierarchical feed-forward neural network and creating the feed-forward neural network training.
So that is the novelty that you mentioned.
Hello?
That is the novelty.
Yes, sir.
And,
The,
yes. Okay. Okay.
the
And as you have, I hope I am audible clearly. Yes.
yes, sir. You're very much audible.
Yes. Yes. As you have mentioned that using the random forest, you have achieved 28.7 accuracy, right?
Yes, sir.
Yes. Yes. So, are there any strategies that you are considering to, further improve the model accuracy or
Oh,
robustness
yes,
of
sir.
the? So,
Along with
can you?
this, we could use transformers like the self or cross transformers, like cross attention and self attention transformers, so that we could get the more detailed analysis of the context. Like in a encryption, to find the randomness, we could like use the attention mechanism here, so that we can get more context in the same ciphertext and using self attention and cross attention for comparing with the other parts of the ciphertext.
So, do you think that will help you to improve the accuracy? Is it so?
Um, yes, sir. I mean, I did try using that, but then the accuracy was failing and our deadline was also coming nearby. But with enough resources and enough trials, I think we will be able to get like we would be able to get more accuracy using attention.
Last question. How do you see this framework being applied in a practical cryptography or cyber security task?
Yes, sir. Like the
How do you
example I
see?
gave initially,
Mhm.
like the example that I have given initially, where we could use it to debunk the ransomware. Similarly, there could be more applications to it, even in the defense sector, where there is so many uh, encrypted data that goes here and there for reconnaissance and all that kind of activities. We could use this. Like this wouldn't this wouldn't create something new, but this would make the process much more accessible and easier because it is generally very difficult to get which algorithm it is used to encrypt data. because they're all so similar. This gives a we are using AI to do this. We are using AI to leverage this process faster.
Okay. But please work on the accuracy part, right? Thank you. So
Yes,
that's all from
thank
my
you.
side. Anushma, please. Thank you.
And this is exactly why I really like coming to these kind of sessions, because they can be interdisciplinary. And Dr. Vivek just asked the kind of questions I would have liked to ask. So first of all, I'm very happy being a non-technical person. Parth, you started with a fantastic scenario. Like, it really made it very clear for everyone about the application. And building on to what Dr. Vivek has asked, my question would also be something similar. So you're saying you're still working on the accuracy part. My question would be, as someone who's coming from like a more media ethics kind of a background, what are some of the things that can go wrong? Like, as you said, this is a system. It can fail at times. Do you envision things going wrong? And if yes, what kind of things can go wrong?
Okay, right now the top of my mind is just as any other cyber security related application that we are able to engineer. The things where it can go wrong is it landing in the hands of people who might use it to do something malicious, right? Uh, like like I have been presented about my project before, and one of the questions that the jury members asked is, what do you like? How do you say that your project cannot be used for malicious reasons? And to that, my answer is, I think it's part of the responsibility of the owner of the product because at the end of the day, we all engineer things. We all create stuff that could either help the world or destroy it. So it is in the hands of the people who are using it to use properly. Like if there is a pen given to a child's hand, they can use it to learn how to write beautiful poems or how to create something new, or they can use it to poke the eye out of the person sitting next to them. So I
Agreed.
think it is.
I understand that. I'm sorry to cut you off here, but as just like ChatGPT, sometimes it hallucinates. So I understand it going in the wrong hands. However, the output, I'm asking from the output perspective, what could go wrong in the output itself? Where, like, for example, ChatGPT can hallucinate, or it can produce like seven fingered hands, right? So where can your output go wrong?
Oh, yes, ma'am. That is a very good question. Sometimes it could predict, like the classification that it does could be wrong. It might not be completely true. It can be a black box kind of a situation where it will just say, yes, my classification is this, this is my verdict. So you just have to do it. But for that also, we have engineered something called SHAP analysis, where it is not a black box scenario. It is able to tell why it took a particular decision that it took. Like it will say, I have gone through like this particular feature. Let's say entropy. This entropy is like this. That is why I'm classifying it as let's say AES algorithm. So it gives a confidence level of how much confidence it is giving on its verdict and why it is choosing what it is choosing. I think I forgot to mention that while I'm presenting. But yes, the where it can go wrong is in the classification part. But there also, I think we have taken care of because we are implementing SHAP analysis that makes that makes sure it's not a black box. There is a justification to the verdict that it has come up with.
Okay, all right, makes sense. Good job. Thank you.
Thank you, ma'am. Thank you, jury.
Yes, thank you, Parth. Now, next, I would like to call Megha Poddar to present her research on an advanced graph neural network framework for modeling dynamic cyber network topologies and detecting anomalous behavior patterns. Megha Poddar or any of the co-authors? All right. Hamid Reza Khalaikzadeh, sir, are you present?
Hello, good morning, everyone. Sorry, good afternoon, everyone.
Yes, hello,
Uh,
sir. Please present your study on enhancing e-commerce sentiment analysis using fine-tuned Robert and Bert on women's clothing reviews.
yeah, okay, yes, let me share my screen. Is my screen visible?
Yes, it
So
is
we
visible.
can see your Google Translate page.
Screen is visible, but presentation is not visible. Now screen is on.
I shared my entire screen. Let me try it again. Share and entire. Okay. So here, share. Is it visible now? It's visible now?
Now,
Yes, sir. Yes, sir. We can see your PPT.
Okay.
Yes, it is visible now.
Okay. Thank you so much. Um, Hello everyone, my name is Hamid Reza and today I want to present our research work titled Sentiment Analysis in Women's Clothing E-commerce Reviews. I know that all of us familiar with reviews and it's important in online shopping or even in store shopping because reviews directly influence the purchase behavior and customers' decision making. When we want to purchase something, so we first try to go through some reviews to better understand the quality of that service or the quality of the item we want to purchase. Uh, these days we are in big data era, and every day or even every minute, a large volume of reviews are generated, and consequently, it is impossible to review and analyze all these comments and reviews by human. And it means that we need automated systems to understand the meaning of these reviews and classify them based on their emotions and sentiment in, for instance, three main groups like negative, positive, or neutral. Developing um, sentimental analyzers mainly rely on natural language processing, and processing text becomes complicated when we have some ambiguity or, for instance, conversational expression or domain specific slangs in reviews. To address these issues, uh, these days we use transformers, like for instance Bert, Roberta, to process text, to understand the meaning of text, and after that, make classification. And the main motivation of this research is to use transformers to implement sentimental analyzer for women's clothing reviews. Before going through the technical details, I would like to have a very quick overview on the evolution of sentiment analyzer. Before the emergence of machine learning models, sentimental analyzer mainly developed based on rule-based and lexicon methods. So as you know, in this approach, the system is mainly depend on a few rules, or for instance, a subset of words in form of a dictionary, and based on that dictionary the system make decision and classification decisions. So we know that in these systems, because the system has access to a subset of words, classification cannot be done accurately. So next alternative, definitely, is to use machine learning techniques, like for instance, SVM, random forest model, so on and so forth. But we know that machine learning techniques, like for instance, random forest, they are suitable for processing structured data. And when it comes to sequential data and unstructured data like text, they cannot understand the meaning of sequential data very well. There are some techniques, like for instance, encoding text into some, I don't know, strings, and then use that strings as input to traditional machine learning models. But anyway, this encoded text cannot reveal the actual meaning of uh, review and comments. Uh, so deep learning and GPU computing is another alternative. And in deep learning era, we can use, for instance, RNNs and LSTMs for sequential data processing and processing reviews. So obviously, RNNs and LSTMs are powerful to understand the context, like textual context. But the main drawback of these deep learning models is performance, because they cannot process text in parallel. And that is why, these ways we have the best alternative known as transformers, like for instance, BERTs, Roberta, so on and so forth. And by using these transformers, we can process sequential data like text and comments and reviews. And in terms of performance, because they can use GPUs and they can process text in parallel. So definitely, we have accurate models, and also uh, we have efficient performance in terms of computation. So in this research, we utilize fine-tuned transformers to implement sentimental analyzer on women's clothing reviews. We used three main transformers: Bert, Roberta, and Albert. Bert is just a baseline. Roberta is a more advanced version of Bert. We have also decided to use Albert because it's efficient in terms of computation. So it shares some because of parameter sharing. We expect to give us better performance compared with Bert and Roberta. For implementation, Hugging Face and PyTorch used, and also we used a wide range of evaluation metrics, as you can see some of them in here, to understand to complete our benchmarking, and also our models compared with a few models implemented by some previous works. Okay. So for training and test, we need a data set. We downloaded a data set from Kaggle, and this is just the title of data set on Kaggle. The data set consists of around uh, 23,000 samples. There are 10 features in that data set, but in this research, we only used review text and rating. The data is labeled as 5 class or 5 star rating system. We also transformed the data and created another data set consisting of 3 class model. So to scale down the rating classes from 5 to 3, as you can see, we use, for instance, 1 and 2 to ratings as negative, 3 as neutral, and 4 and 5 star reviews as positive reviews. So we use 3 class and 5 class uh, uh, data sets for training and model evaluation. So in here, we can see the implementation pipeline. So our data set, after that, the data set pre-processed. In here, we have all the pre-processing steps. So first cleaning data, tokenization, and encoding, and then 3 fine-tuned transformers trained. And after that, it comes to prediction and model evaluation based on 3 class and 5 class uh, models.
Yes, sir.
Uh,
Reminder to conclude the presentation in the next minute.
okay. So and here we see the key finding, as you can see, and as we so in here, Roberta gives us the best performance compared with Bert and Albert. So in both classes, three class and five class data sets, and if we compare Bert and Albert, we can see, there are very comparable. So, but it should be highlighted that Albert is more efficient in terms of computational uh, performance. So, table one summarize the evaluation results of our model. So, as we can see, for three class model, we achieve accuracy around 85%, 5%. But for five class data, so it's around 70%. In here, because we use the same models for three class for five class prediction, and so table to present results for a previous work, and in here for three class implementation, we outperform the work performed by Biller. But for five class, so they obtain better results. However, our model is better in terms of AUC uh, evaluation metric. And to conclude, so Robert can outperform all other models in woman clothing review processing. And based on the comparison between these two tables, we can conclude that when it comes to domain specific fine tuning, we can obtain better results. And we had some limitations, for instance, class imbalance, especially for five class labels. And yeah, that's it. Thank you so much.
Okay, Vivek sir, any questions for him?
Audible? Yes.
Yes, sir.
Hello, am I audible? Yes.
Hello.
I hope I'm audible.
Yes, sir. Yes, sir.
You are audible.
Yes, 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 yes. Thank you. So, sir, could you like elaborate that what challenges did you face while analyzing this sentiment in the e-commerce reviews? Did you face any challenges?
So the first challenge is that, as I mentioned earlier, for five class classification, we couldn't achieve high accuracy. And
Correct.
to fix that issue, definitely, we have to improve our fine-tuned models, the architecture of our models. But because because in rising the computational cost, we just couldn't just implement more complicated, more complex models and train them. This is one of the challenge. And the next challenge we try to include in these models is to just integrate aspect based sentiment analysis. uh, uh, but we just give it a go, but we couldn't obtain uh, promising results. And that's why this is our future plan to try to include that feature in our sentimental analyzer. And definitely it will help to give us to classify the sentiments, but from different points of view.
Okay, okay. So, are there any strategies that you have planned to enhance the what we can say that accuracy further? Do you have any plan, any strategies?
So for plan, um,
Have you
just
identified any strategies? Sorry to interrupt.
yes,
Have you
yes.
have you
So
identified any strategies for that?
the first strategy we need to just take is to address the imbalanceness in the data set. So we need to make just the data set balance, especially for five class uh, sentimental analyzer. And the next thing we need to just implement so improve the architecture of our model for five class uh, analyzer. And in here we can just increase the number of layers, or even the other option is to, for instance, implement hybrid models. Okay, so to allow our models generalize better for 5 class predictions.
Okay, thank you.
And I have a question as well. Hamid Raza, really, really good presentation. But as you know, life is actually complicated, right? Uh, Comments and reviews are not just good and bad. What if I give a
Mhm.
comment like, oh, the product was great, but the size is not good? So it's like
Yeah.
multiple messaging in one sentence. Do you have any way of like handling it? Have you encountered such kind of uh, data?
Yeah. So good question. Uh, so in the current version, okay, so we consider the whole review as whole, okay, and then so based on the context, so the system says that it's positive, negative, or neutral. And that is why it's very important to include aspect-based analyzer to the model. Okay, so for instance, suppose you have a comment and say that, okay, so in terms of color it's fine, but in terms of, I don't know, for instance, the style is not. Okay, so in here, if we just add aspect-based analyzer, so it says that, okay, so in terms of size it's positive, but in terms of color is negative. So and as I mentioned a few minutes ago, that is why our next motivation is to add aspect-based feature to that analyzer.
Yes, absolutely. Otherwise, I think today retailers will lose a lot of data. I think it's a gold mine actually. I think it has a very strong potential for it to be adopted in the
Yeah.
business world. So all the best.
Yeah. Yeah. Thank you so much for your suggestion. And definitely, we need to add aspect-based sentiment analyzer to that model. And, in here, we just, the main objective of this research is to show that if we just, developed models, developed analyzers for domain-specific areas, like, for instance, clothing or any other, specific domains, we can achieve better performance than developing a general analyzer.
Okay, thank you so much, sir.
Thank you.
So next I would call Ravi Honali to present his study on enhancing threat detection in cloud environments through temporal anomaly modeling.
Yes. Is my screen visible?
Yes, sir.
Okay. Good afternoon, everyone. I am Ravi, and today I will be presenting our research work titled Enhancing Threat Detection in Cloud Environment Through Temporal Anomaly Modeling. This work focuses on improving cloud security. Yeah. This work focuses on improving cloud security by reducing missed threats using a hybrid model approach. Okay. Cloud computing is widely used today, but it introduces complex security challenges due to dynamic and distributed environments. Traditional security systems fail to detect many threats, especially in real times. In security, missing a threat is very dangerous. So our focus is on achieving high recall, that is greater than 95%. High recall is equal to fewer missed attacks. And our research gaps and objectives are we identified four major gaps in existing research. Most models use either ARIMA or LSTM, not both. Recall is slow, only 75 to 85%, and limited usage of meta learning for combining models, lack of real world deployment system. Our goal is to overcome all these limitations. We aim to achieve greater than 95% recall with a production ready system. And some of the related works are as displayed here. Existing work use combination of machine learning and deep learning such as random forest, CNN, LSTM. However, they either focus on logs or network data, not full cloud metrics. Also, they lack proper temporal modeling and fusion strategies, so there is still a gap in combining temporal model effectively. And methodologies would be like this. There are three-tier architecture. Our system has three-tier architecture. Tier 1 base model, we use ARIMA for linear patterns and LSTM for non-linear temporal patterns. Tier 2 meta learning. We combine outputs using models like random forest, XGBoost, and neural networks. Tier 3 is deployment. We deploy it as a real-time API with less than 200 millisecond latency. This combination allows us to capture both simple and complex pattern in cloud data. And here are our project results. Like we evaluated multiple models and fusion strategies. Hybrid random forest gives the best balance with 95.75% recall using only ARIMA and LSTM. We use ARIMA because of its very low recall and LSTM because we use both of them, not individually. Hybrid because hybrid model gives the best performance. This proves that combining models is more effective than using a single model. And the confusion, sorry. Yeah. Yeah, confusion matrix and recall result. Out of all anomalies, only 4.25% were missed, which is very low. In security, false positives are acceptable, but false negatives are dangerous. And key findings for our projects will be: we observe four key findings. Hybrid models significantly improve performance, and meta learning is better than rule based methods. High recall requires accepting low precision. The system is production ready, and we compared it with other literature surveys also. Our model improves recall by 10 to 20%. Most existing systems do not combine temporal modeling and meta learning like ours. Here are the conclusion and major contribution of our project. We proposed a hybrid ARIMA and LSTM model with meta-learning fusion. We achieved 95.75% recall, which is significantly reduces missed threats. This help organization detect more threats and improve cloud security. And our future work and research direction will be like in future if we have to make it some changes like multimodal detection, add explainable AI and federated learning. And this was conducted in our college, Nitya Meenakshi Institute of Technology. Okay, thank you. If you have any questions, you can ask.
Yes, I think I'm audible.
Yes, sir.
Yes. So as you mentioned that you achieved the 90% recall accuracy, right?
95.75, sir.
95 points, right, right.
Yeah.
So this is in your temporal anomaly detection, right?
Yes, sir.
Yes. So could you explain what strategies or features that contributed most to high recall?
We can use we can actually use more networking parameters, or we can high anomaly sensitive or handling class imbalance, and we can also try combining different models with it, so we can achieve the higher score.
Okay. So this high recall will is consistent in the dynamic environment. What do you think?
In dynamic environment, wait, well, if we add a continuous learning AI model, then it will be dynamic, sir.
Any example?
Um, like mm, mm, I can't think of it right now.
Okay, no problem, no problem.
Yeah,
So overall presentation was good.
yeah. Thank you, sir.
So the last question, uh, does your approach differentiate between the like benign and malicious temporal patterns? If so, then you can explain. Otherwise, no problem.
Yes, it uses temporal patterns and anomaly scores to differentiate. and malicious like sudden spikes, irregular in network usage or non-linear deviations like that.
Okay. No. Thank you. Thank you very much.
Yeah.
I just have one question. Good presentation, first of all. So I may have missed that information in the beginning, but did you collected data from a specific organization? You
No,
don't
it
have to
was
tell us.
the
Mm.
Kaggle data set.
Oh, it is a data set. Okay. So is your work here in this, if I'm not, it's a temporary anomaly model. Does it work on multiple in multiple scenarios like hospitals or say, for example, banks, other
Uh,
organizations?
uh, for now, we have like mostly related to IT tech sectors only, but
Mm.
we can try to implement in on other sectors also.
That would be lucrative. Like if you are able to get a system running for multiple organizations, I think that is something that would add to the practical value of your research, right? I think
Yes.
because human beings have different needs and organizations have different needs. So if your system can cater to multiple situations, that would be something that you can monetize.
Yes. Yeah.
Okay. All right. Fantastic.
Okay. Thank you.
Yes, thank you, sir. Now, next, I would call Saurabh Nimje to present his study on evaluating AI-based diagnostic models for cervical spinal stenosis detection using magnetic resonance imaging. Saurabh Nimje,
Yes,
sir.
ma'am. Ma'am, I am not able to share the screen.
Sir, can you please try again?
Yes, ma'am. Hope so my screen is visible, ma'am. Hello.
Yes, sir. Yes, please start.
Thank you, ma'am. Hello, everyone. Good afternoon. My name is Saurabh Nimje. I am a MTech student from Dattamege Engineering College, DMIHER, India. These are my contents. Cervical spinal stenosis, CSS, is a serious condition caused by narrowing of a spinal canal. Can lead to neurological damage if not detected early. MRI is a gold stand for spinal diagnosis. There is some challenges in a traditional diagnosis. One is manual interpretation, time consuming, and inter observer variability. So using AI model, we can automate diagnosis, improve accuracy, and reduce human error also. So existing, so there is a traditional diagnosis, MRI based manual analysis, and radiologist interpretation. Using a machine learning model, there is a two model, support vector machine SVM and random forest. When we using a deep learning model, there is a two model CNN and transfer learning means REST-NEST 50. And there are some limitations, limited automation, lack of consistency, and limited interpretability. These are problems in existing approaches. So first problem is manual diagnosis is a subjective and time consuming. Early stage CSS is a difficult to detect virtually. Traditional machine learning model are failed to capture complex pattern. Lack of explainability reduce clinical trust and high chances of diagnosis error. My objective is compare AI model CNN, ResNet 50, SVM, random forest. Second, evaluate performance using standard matrix. Third one, identify best model for CSS detection. Fourth one, improve interability using SHARP. And fifth, develop clinical reliable AI diagnosis system. My proposed methodology are I take 1200 MRI images, T2 weighted, Step 2, pre-processing. There are normalization images. So using in that images, we talk about pixel values. Then segmentation, focus on spinal region only. And third one is data augmentation, where one image we can convert in multiple images using rotation, flipping also. So one image I convert in 10 or 12 images. So 1200 images is converted into nearly 12 to 13,000 images. Step 3, model development. So I use 4 models: CNN, ResNet 50, support vector machine SVM, and random forest. Fourth step, I split data in 3 parts: training 70%, validation 15%, and testing 15%. In evaluation, I calculate accuracy, precision, recall, F1 score, AUC curve also. And last, explainability, I use a sharp used to identify important features. These are my results. So using 1200 MRI images, original 1200 MRI images. So model performance given by the ResNet 50. It is a base model for my paper. So it gives accuracy 93.6%, F1 score 93.7%, AUC 0.9%. As also CNN SVM also gives some accuracy. So CNN give 91.2%, SVM accuracy give 85.1%, and random forest give accuracy 87.8%. There are some key insights for my papers. So deep learning model outperform traditional ML model. Next, ResNet 50 provide high accuracy and low error. And third one, sharp identify important clinical features for my paper. So there is a performance comparison between CNN, ResNet 50, and SVM. Here we can compare accuracy of ResNet, accuracy F1 score, all AUC curve also, it give high than other CNN and SVM. So conclusion for my paper, first one, AI-based model improves CSA detection accuracy. ResNet 50 is the most reliable and effective model. Deep learning outperform traditional machine learning method. Sharp improve interpretability and clinical trust. And fifth one, system can support real world medical diagnosis. There are some future words, scope of future words also. So first one, use larger and multi-center data set, because we are using only our institute hospital data set. That's why. Second one, improve explainability using advanced XAI. And third one, apply multimodal imaging approaches. These are my references, and thank you.
Vivek sir, any questions?
I'm on. Yes.
Yes.
Yes, sir.
Clear. So very nice presentation,
Thank you.
Saurabh sir. Yes.
Yes, sir.
As you mentioned that you have used 3 models, right?
Yes.
So why don't you have used that ensemble approach to boost your accuracy?
Sir, for we can say it is a good idea, ensemble, but for me, I want to try different 3 model and take accuracy and compare with it. This is my next step, sir. Assemble the multiple model and work on it, sir.
But that will help to boost your accuracy, right?
Yes, sir. Yes.
Yes. So okay, as you have mentioned that that you are going to use that explainable AI, but you have just
Yes.
mentioned you are using that advanced explainable AI. What does it mean?
Explainable AI
Right.
means I using Sharp. Yes.
Yes, please continue.
For the detection, so MRI images maybe sometime is not good. So that's why using Sharp, you or we can say increase their accuracy of our model. So you getting MRI images, work on it using some techniques to clear or anything to images and apply to our model to get a higher accuracy.
Okay. So, do you really think that improving that explainability help the doctors, or we can say radiologists, to trust the model's prediction in real world
Yes,
clinical
sir. Yes,
settings?
because sir, I took data from our institute hospital, and this model we apply in hospital also. So compared with the previous, the accuracy is increases.
Okay. Okay. Take it. Thank you. Good.
Thank you, sir.
Ashavari ma'am, any questions?
No questions from my end. Thank you.
All right, thank you very much.
Thank you, ma'am.
Next, I would like to call Sanath Shetty to present his study on image in painting with restoration and resolution enhancement.
Am I audible?
Yes, sir.
Is my screen visible?
Yes, sir.
Good afternoon, everyone. I am Sana Chetty, student of PS University, India, going to present you our work, Image in Painting with Restoration and Resolution Enhancement. This work focuses on restoring damaged images while preserving the structure and the context of the image. Coming to the problem statement, our project Image in Painting aims to restore the missing region and the damaged regions in the image. While restoring images, it is a difficult task to preserve the structure and the fine details. So we are focusing on preserving the structure and the fine details of the image in our project. Existing method will fail when the damage is complex, like scratches, noise, and blur. Real world application of our project is old photo restoration and the digital archives. Proposed solution. We use GAN based architecture for our project, where gated unit is our generator and spectrally normalized patch GAN is our discriminator. It handles multiple images like scratches, noises, and blurry images, produces high quality and visually consistent restored images. Coming to the implementation details, data set constructions and augmentation. As we are using GAN model, it requires a very huge data set. Since it is very difficult to collect real world damaged images, very huge, so we thought of synthetically generating the data set using the Celeb data set, which is there in the Kaggle, which is almost around 20,000 plus images of various celebrities, facial images. Then the pre-processing, we resize the images in 256 into 256 pixels, and normalization is done. Then we created triplets of images of damaged images, masked images, and ground truth. Ground truth is the original image, and original image is introduced with the scratches, noise, and blur and stains to convert it into the damaged images. And we used various tools like grayscale, sepia turn, and brightness changes to convert the original image into the damaged images. And coming to the generator, we use gated unit as the generator in our model. It follows an encoder-decoder architecture with skip connections, which helps in preserving the fine details. And the encoder, which will extract the features, and the decoder reconstruct it back to the high resolution. And we used gated convolutions, which helped in model focus on valid regions and ignore the corrupted areas by putting 1 for the valid regions and by putting 0 for the invalid regions. And additionally, we include dilated layers in the bottleneck to capture global context. This overall design helps in restoring both structure and the texture effectively. Coming to the discriminator, that is spectrally normalized patch GAN. We, unlike traditional GANs, evaluate the entire image. Patch GAN works at the patch level, focusing on the smaller regions of the image. This helps in capturing fine details and improving texture realism. We also did spectral normalization to stabilize our training and also improve the consistency. Coming to the training methodology, we trained the model using a combination of multiple loss functions, including reconstruction, perpetual, adversarial, and feature matching losses, which helps in the aspect like accuracy and visual quality. And we also used Adam optimizer to make our work more efficient. And the generator and discriminator are trained alternatively. We also apply stability techniques like spectral normalization, gradient clipping, and label smoothing. And finally, we use the sliding windows if the image is very large. Model testing and evaluation. Model is basically tested on diverse damaged images, where the input we have inputted with the damaged image and the masked images, and the output it was giving a restored image. We evaluated using PSNR and SSI matrix. PSNR is peak signals noise ratio, and SSM is structural index. PSNR that we achieved is 27 to 28 decibels, and structural similarity index that we achieved is 0.8 to 0.9, which is a lot better compared to the other studies. Produce visually realistic and artifact-free results. So these are our testing results. These are the synthetically generated damaged images, which is augmented by us. And these are the second row gives us the image that is produced by our model, and the final row is the original image that we used to create the damaged image. These are the several other models which creates the which are used to inpaint the damaged images. Here the problem is the AI models that has been used here is not retaining the context of the image, or the structural similarity is different completely. You can observe like our model is basically retain the context as well as the structural similarity. And conclusion here. In the conclusion, we developed a GAN-based image inpainting framework using a gated unit and the spectral normalized patch GAN. The model achieves high quality restoration and accurate structure and realistic textures. We obtained strong performance in terms of PSNR and SSI matrix, as you can see. And our augmentation pipeline helps in simulating the real world damage conditions. Overall, the model demonstrates strong potential for applications like heritage restoration as well as digital archiving. Future work. Like we improve the model performance by training with the real world images, enhance the restoration quality, and when the damage is very huge or complex, sometimes our model fails to restore it, and expand the dataset with the real images. Thank you.
Vivek sir, any questions?
Yes. First of all, very nice presentation, right?
Yeah, thank you.
Yes. As you have mentioned that you have used the synthetic data set, right?
Yeah.
To train the GAN architecture. Okay.
Yeah.
So that synthetic data impacted the model performance?
Yeah.
Do you think so?
It actually impacted, since it was very difficult for us to collect the real world images, damaged images. We could collect only around 1,500 real world damaged images. So as GAN model requires a huge data set, it was very difficult task for us to collect the real world. So we decided to generate it synthetically.
Okay.
Yeah.
Okay. And so you have mentioned that you have uses like various loss functions, right? So
Yeah.
could you please explain which losses contributed most to improve the in painting quality or resolution enhancement? You use various laws, right? Reconstruction laws and the other laws as well, right?
Reconstruction laws helped us a lot because each it helped in accuracy, increasing the accuracy, and the perpetual loss helped in knowing whether the image looks similar or not, and the adversarial loss helped us to know whether the image is real or not. That's it, sir.
Okay. So, is the main what are the main challenges do you think that in balancing the restoration of quality?
The main challenge is like when the damage is very huge or very complex, sometimes our model fails, sir. Like when the damage is like if it's small, then it easily restores. But if the damage is huge, then the maintaining the context will be difficult of the image. And also
Okay.
collecting the data set was a huge task for us.
Okay.
Yeah.
Okay. Thank you. Yes, Dimai, please.
Ma'am, any questions?
Yes.
Yes, actually, I don't have a question, but I have a comment. Sanat, I think we should. I don't want to like let out any collaboration opportunities, but we need to exchange notes because I feel we are working on something similar. Our media department here, we are talking about AI's cultural blind spots. Okay, so in fact, in the morning we just presented in a different setup. We were discussing how AI has cultural blind spots, and when you're training the model, you really have to take that into account because it is probably getting some information about beauty standards. They are cultural, and it learns what is natural and what is considered conventional from this training data. And different cultures have different standards about beauty, and your system actually might change faces to match some specific standard, rendering the process sometimes unfair. So this is a challenge that you will, I think, face. So let's perhaps offline exchange some notes in a scholarly spirit and see where it takes us. But this is a fantastic topic, and I think it has a lot of potential, considering AI models have a tendency to like make up data as well, right?
Yeah, ma'am. Thank you.
I don't know if I don't know if you're agreeing with what I'm saying, or you don't have to, but this is something that we've discovered as well. Okay, so just a comment for you in future.
Yeah. Sure.
Yeah.
All right, next up, I would like to call Padinjaruth Monesh Raj to present a study on music control using hand gesture recognition and audio reactive visualization. Monesh Raj, sir.
Yeah. Good morning to all.
Yes, good
So
morning.
today's my project is on music control using hand gesture recognition. So can I share the PPT?
Yes, sir.
Can you see the PPT now?
Yes, sir.
Yeah, this is my project, music control using hand gesture recognition. So let's see what are all the topics we are covering today. First one is problem statement and motivation. So what made me to do this project? There are more current systems which uses hand gestures to command things. I have used this hand gesture recognition to control the music, or only a single camera is required to do this. So these are the difference between the past systems and the current system which I have built. So current limitations: the existing system require costly hardware, sensor gloves, and infrared cameras. These are all the systems which are required. But we use only the webcam which is inbuilt to your laptop, or can be webcam which are connected as a hardware device outside. So high barriers for accessible in resource limited environments means the camera quality is required, and some of the other hardware systems are required in the past limitations, but we use real-time hand gesture recognition. The main model of this project is MediaPipe. So MediaPipe is built by Google, so that the gesture recognition has achieved for 96% to this media pipe systems. So this is a Python library. Whole project is built with Python. So minimal visual feedback. User gets no immersive response to their gestures. Means if we use our hands, it spots every spot of this gesture. So MediaPipe has 21 landmarks in our hands. So those 21 landmarks are connected to our hands if we show the hand to the camera. So this is 3D audio reactive visualizations. There are projects which are separated by hand gestures and visualizations are separate. We have combined both in single project. This is the problem statement. The next one is end-to-end pipeline. First one is webcam input. So the webcam input is directly taken from our webcams which are inbuilt in our laptops or systems. So after capturing the every frame, it goes for hand tracking. Hand tracking. MediaPipe has 21 landmarks. Our hand has 21 landmarks and its accuracy is about 96%. Next one is gesture classifier. It is a geometric feature which classifies the gesture. So if we show our palm open, then it has some models trained to it previously and stored. So those features and those systems can be implemented in this. Next one is command mapper. So for example, I have given play and pause for if you open the palm, it pauses the music. If we close the palm, it continues the music. And if we open an index finger, then it goes to the next track of the music. If you open the little finger, then it goes to the previous track of the music, and stop and volume control is also there. The pinch of our index and thumb finger shows the volume control of this music systems. So these are very useful in while, for example, we are driving a car, so we don't need to connect our hands to the media player or anything which is hardwarely required to operate the systems. We can directly just wave our hands or show our hand systems to change the music. Or this is not only for the music control, but the hand gesture recognitions are used in many technologies nowadays. The next one is gesture recognition pipeline. This is the gesture which I have trained before to operate in the system. For open palm, pause the music. For closed fist, stop playback. Thumb up, increase volume, and thumb down, decrease volume. These are the tips which I have trained. It uses convolutional neural network for tracking the hands. So the next one is Tone.js. Tone.js is nothing but it is a software where music is taken from this Tone.js website for higher quality music to implement in this. This all project is a web-based project, so anyone can access. There is no software required, or there is no separate running of a program is required. This is a web-based project, so anyone can access this project. Next one is 3JS. 3JS is nothing but interactive 3D scenes. Means it shows the 3D design visualizations which are accordingly drawn or accordingly reacted through the music. If the music plays, we have different types of music, jazz, beat, or anything like this. We have different types of music. According to that music, the beats gets visualized in our project for interactive sessions with users. So the user gets more connected to this project with 3D visualizations. So the real world use cases, assistive technologies. So for a blind people who are unable to contact directly with the hardwares can use this project very simply with their hands, which who can control their music with their hands. Next, creative performance like DJs, performers, or digital artist control effects. They can use this project, or educational demos for computer vision. Not only for music control, it is hand gestures are used in various topics of our education. So next, public touchless interface like museums, airports, or public spaces for hygiene browser delivers. So these are the key takeaways. Fully browser based, zero hardware or zero installations are required. Real-time media pipe for 21 landmark precisions, Tone.js for audio engine tightly synced with gesture commands, 3JS for 3D visualizations for interactive with users, inclusive design supportively visual impaired users. So this is the end of our PPT and end of my project topics.
Vivek sir, any questions for him?
Okay. I hope I'm audible. Yes.
Yes, sir.
Yes. So nice presentation, right? As you mentioned that your system is fully browser based, right?
Yeah, yes.
Yes, yes. So can you focus on like how does that browser based approach handle the latency issues? Like
Latencies,
comparatively, let
latencies doesn't take away with this browser based. Like the system requirements are so basic. Like uh, it can be worked on 4 GB RAM systems or 8 GB RAM systems. It does not take the system requirements so impartially.
because especially when we are dealing with the real time music control, that's why that was the thought process behind that. That's why I asked this question, right? How does
Yeah,
this
sir. Yeah,
approach
sir.
handle? Okay. Uh, okay, that's all from my side. Thank you. Thank you very much.
Okay, good.
Yes, Ashavari ma'am, any questions for him?
Hey, again, very nice and interesting research. Have you tested this with people? Have you tested it with, say, musicians of different abilities?
Yeah, ma'am. It is the final year project of my college, so
Okay.
it has converted to many project expos also.
Mm-hmm.
So they have used it and said it is more reliable to users.
Okay, great. And you've tested with people from different cultures as well?
Yeah, ma'am. This music control is nothing but we upload a MP3 file so that
Mm-hmm.
those MP3 files get played. So any music or any cultural people, their music can be uploaded in here like .mp3 file. So those
Mm-hmm.
musics can be played. It can be implemented in also Spotify or some music apps, so that those apps can be implemented with this project also, ma'am.
Okay. And you said that you in the beginning you said something about, say, the visually impaired individuals.
Yeah, yeah, ma'am.
Have you spoken to them at all?
No, ma'am, I thought it is very useful for them because searching a button or searching a key
Yes.
does not make them very feel like it is gonna be this button or this play button or this is pause button. So they can directly implement with their hands right now.
Absolutely. That is why I'm saying they can be one of the target audiences for this research, and I think it'll be of merit if you could include them in the discussion, talk to them, get some feedback about your design from them, and I think that would
Yeah,
be something that you could like work on as well later, not necessarily
yeah,
now.
yeah, ma'am.
But,
Yeah, ma'am. Sure.
okay. All right. That's all. Good job.
Yes, thank you so much. Now, next, I would call Aditya Ajitrao Kulkarni to present his study on Printify, a real time location based service platform for document printing and digitization, featuring a progressive web application for shopkeeper operations.
Hello, am I audible?
Yes, sir.
Just a second, I will share my screen. Is it visible?
Sir, we can see your Zoom screen currently, not the PPT.
I had updated it. It is not visible.
No, sir.
Just a second. Yeah, is it visible now?
Yes, sir.
Yes. First of all, good afternoon, all the respected panels and all the participants. So today I am presenting our paper that is Printify, a real-time location-based printing platform. My paper ID is 150. Author, I am the main author Aditya Kulkarni. Co-author sir Saurabh Gonte, Kalpak Kedari, and Parikshit Jadhav. And I had completed my project under Professor Miss Mayuri Sherke. So I belong from the college MMCOE Pune. So regarding the introduction of our project, first of all, in today's digital world, there are many services on demand. For example, food, transport, shopping, but printing services still remain largely offline and inefficient. So we had built a smart printing platform that connect users with nearby printing shops. Majorly the key features include you could locate the shops, upload PDFs as well as various documents, having a secure payment gateway, as well as track and have a invoice to monitor all the status and receive the invoice as well. Regarding the problem statement, the traditional printing today faces several challenges inside the India. Users must physically visit the shops and wait in the queues. There is no real-time visibility of nearby print shops. Pricing is unclear and inconsistent. Existing solutions mainly target corporate environments, so it lacks proper application or platform to provide all this solution for all this. So there is a clear disconnect between digital users and local print vendors. Research gap. There is no existing platform combines real-time shop discovery, instant payments, and custom print preferences in one place. So basically, there is no such app which provides everything in all in one platform, which includes real-time discovery, payments, custom print settings, order trackings, etc. Printify addresses this gap by creating a unified, user-centric, and local first ecosystem. Basically, this is our system architecture. We have Xerox shop owners, admins, customers, and delivery partners on the user side. Uh, for user, there is Android application which is developed using Flutter, and shopkeeper has a React website which he could access through his phone, which is progressive web app, or is through website, laptop or its computer. So we upload a document from user side, which is sent to the shopkeeper side. Uh, he prints the particular he prints the particular document and notifies whenever the print is being completed. So user for workflow. So basically there are two main users in our application. One is a normal user or customer who is using our application. So first when he will open our application, he will locate the shops, finding nearby print shop via GPS. Then he would select shop and upload the document. Then he would customize the settings, which includes various prints preferences, like for example black and white color, back to back, etc. Then our document will be uploaded and stored into the Firebase, which is a secure storage. He will perform a payment via Razorpay. We had implemented Razorpay gateway. Then when shopkeeper will accept the order, user will be able to monitor the order status, and finally after order is completed he would collect the printed document. So technologies we used include Razorpay, Android Studio, Java for building an APK, Google Maps API, location services, Flutter, and Firebase for database and authentication. Methodology, similarly for the shopkeeper will receive orders via progressive web application dashboard, which is from Firebase. He would review and approve the request. He could accept as well as reject it. He will process the printing, confirm the payment, and he will update order status whenever order is being completed. So these are basically some images of which I had implemented of our Android app. So this is basically a home page which shows our current location as well as the shops nearby. And the second image shows the order status which is currently going on in a particular shop called Swaraj Xerox and Stationery. The second image includes implementation of shopkeeper side. It is particular a website which is visible to the shopkeeper. How it is basically a dashboard. Both of the images show the same. Regarding future scope, we have various future scopes present in our application. First is AI based document optimization. We could optimize documents, for example contrast, alignment, noise removal, etc., auto print settings, prediction. These are the things which we can enhance in our application. Second is we can use machine learning, various models to get more shop recommendations, demand prediction, and dynamic pricing models. Also, we could create an analytics dashboard which tells us about revenue trends, customer behavior insights, sentiment analysis, and inventory optimization. So the conclusion addresses inefficiencies in traditional printing and lack of integration for the local shops. It provides a real-time service, secure transaction, and cross-platform access, and it supports local vendors through digital integration. It sets a new standard for smart printing solutions. Printify. So finally, I would like to conclude by saying Printify bridges the gap between digital users and local print services, and which is the best solution to the market. Thank you.
Vivek sir, any questions for him?
Yes, only one question. Let's say, how do you ensure if the platform can scale as the number of user grow?
Regarding scaling, sir, we had used Firebase for our handling the database and all. I had tested around 1,000 users while doing software testing. So it handled various software requests because Firebase is in a secure as well as a fast platform. We need to pay according to the price to get more our application scalable. Currently, I am using a free tier, so which limits the number of customers. But when I would put my app for the production, I will definitely buy a plan, and it would help to scale more number of customers.
Okay.
Hmm.
Hello?
Yes, yes, I am audible.
Yes, yes. I hope I'm audible.
Yes, yes,
Yes, yes. Okay. Uh, okay. So you use Firebase to handle the scalability, right?
yes, yes.
Um, okay. So, did you face any challenges with the limits as you
With,
tested for thousands of users? So,
hmm.
did you face any challenges for the Firebase limit or latency?
Pardon, sir, for challenges for what?
Firebase limits or latency of the Firebase. Did you face?
Currently, sir, as our application is under development, in the last stages of development, uh, now I had used a free plan which is efficiently working for about 500 customers at a time, single time. It could handle multiple over a period of time. The challenges apart from this, I faced challenges which includes the shopkeeper rates, because each shopkeeper has a different rates. In India, there are printing Xerox associations which has a standard rate, but when we approached to various shopkeepers, they told that they aren't following the rate. So I had made a uh, dynamically page that where shopkeepers can edit or add their own prices according to their shops. So this was the major challenge which I had faced. But while using the Firebase, I hasn't faced any challenges for the free tier till yet.
Okay. So, do you have any plan when the number of customer or user will increase? That how you will address the progressive web application?
Sir, pardon, because the question wasn't available, audible fully.
Okay, let's say for example,
Hmm.
if the number of users will get increases, right,
Hmm.
beyond
Hmm.
your free limit, right? So,
Hmm.
do you have any plan to address that particular issue
Yes, yes,
in
sir.
the terms of progress? Yes.
Yes, sir. Firebase provides a Blaze plan, which handles a number of customers. We could say a large number of customers at a time. Uh, And one more thing, sir, regarding the efficiency of our application, I had maintained a state where documents which are uploaded will get auto delete within 1 hour, so that it would make Firebase storage much less and improve the
Okay.
efficiency and retrieval speed of the documents from the both the sides, sir.
Okay. Okay. Okay.
Yes.
Thank you. Thank you.
Yes.
Prashavati ma'am, any questions?
Yes, yes. Okay. All right. So again, interesting. I have one question and one comment. One comment is when I was in India a couple of weeks back, I was on Blinkit and I saw that they have a printing service, right? I don't know if you're aware of this, Aditya.
Yes, 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 I am
Okay.
aware of it.
All right, that
Yes.
was interesting. So I think you're going to do something of that nature, but on a different platform. Am I correct? Like, but completely, that your Printify will be completely doing this, but not through another channel.
Actually, ma'am, the issue with the Blinkit is that they have printing machine at their
Mm-hmm.
warehouse, but
I see.
through my application it provides customers to the various local shopkeepers.
Exactly.
It connects user with them, and you could say the rate of the Blinkit, you would say, which is much higher than the normal shopkeepers which
True.
we would use in India. So it is also more economically better way option to choose our application rather than the Blinkit option. And in Blinkit,
Okay.
they won't provide us which with various options of printing printing settings, such as there is A0 printing size, A1, A2,
Mhm.
A3, A4. Lamination is there, spiral is there. They won't provide us all. They only provide just black and white color A4 size.
Okay. The second thing I wanted to ask you is like, how are you really? Is this just a project, or is this something that you will see through? Is it something that you want to productize uh, in the near future?
No, I want to productize this because I'm making my project ready for the production as well. So it is in the final stages of development. So I will deploy it on, firstly, for Android on Play Store. My application will go around 1 or 2 months. I will deploy it on Play Store.
You have to rush a little bit because the Printify domain name is already taken by someone else, right? I don't know if you
Uh,
did that much.
yes, yes, I knew it. I gonna change the name later while
Okay.
deploying it on Play Store.
Excellent. My actual question then is, you have several stakeholders in this project, people who will be benefiting or associated with your project, right? Did you do some audience research with them, some market research around?
Yes, yes, yes.
What kind of
Because
findings did you have, especially
according
from the shopkeepers?
yes, ma'am. Currently, I live in Pune. So in Pune, the area which I live consists of more than 3 or 4 colleges. So from user perspective, I personally faced various challenges while waiting at the queue in various shops during submission times and all. This is basically a major challenge for the students. It's become very hectic. You need to wait for half hours, 1 hours. So I had built a platform for this for the user side. Regarding shopkeeper side, I consistently I'm in connect with more than 5 Xerox associations of my Pune, which includes the Kothurud, Viman Nagar area, Kothurud area, Pimpri Chinchwad area, Koregaon Park area. So these are various areas of to which shopkeepers I'm connecting. I'm taking their feedback every month regarding what they need to connect actually with the customers, and how could we make the process more smoother for them also.
Okay, but did they say anything specific? Did anything interesting come out of that research from them, from say
Uh,
shopkeepers?
Yes, ma'am. During while the Vivek sir said, I had mentioned the major challenge which I had faced was when I visited them. I had made the rates according to the standardized rates which were available by the Xerox Association rates. But every shopkeeper told that we don't follow them. We want freedom to maintain our own rates. So this
Hmm.
was a major challenge also, but I had overcome it. I had implemented a dynamic rate card, so which a shopkeeper would maintain it, and they also like the way of implementing the dynamic rate card, ma'am.
Okay. All right. Well, all the best then. Thank
Yes.
you.
Thank you, ma'am. Have a nice day.
Yes, thank you, Aditya sir. Now, next, I would call G. Venkata Suresh Reddy to present his study on robust machine learning framework for accurate fault identification in solar photovoltaic systems. I repeat, G. Venkata Suresh Reddy, sir.
Hello, madam.
Yes, hello, sir.
Hello, madam. My voice is audible, madam.
Yes, sir, it is a little low, but you are audible.
Hello.
Sir,
Yes,
continue.
Yes,
Dimay?
Hello,
Yeah,
sir.
yes. No problem. Please continue.
Ah, okay, sir. Today I will discuss about robust machine learning framework for accurate fault identification in solar photovoltaic systems, sir. So, contains, this is the, my paper contains introduction of objectives, problem statement, fault classification, PV models. This is the introduction. In nowadays, solar photovoltaic systems has very demanding in global demand for clean and sustainable energy. By increasing and installing PV arrays in residential, commercial, and large-scale applications. So, in PV systems are subjected to face some various problems. Those are partial shading, open circuit condition, and degradation significantly. Due to these problems, reduce the power output and the system performance. So, as well as it will be faces with some problems. Those are the environmental and noise and fault detection. So, in previous traditional fault detection technique is there. In that one, it is face the some manual inspection and time consuming. So due to that one, it will be get less accurate and not suitable for real time monitoring. In nowadays, going to the by utilizing the electric characteristics such as current voltage and power voltage curves, nowadays we are using the machine learning models. From these models, we are getting the fault, different fault condition. We are getting high accuracy. So therefore, so you are developing the intelligent and automated fault detection framework is essential to enhance the reliability and increase the efficiency, and while minimizing the energy losses and operational cost. So main objective of the in my project is to develop a robust machine learning framework for fault detection in solar PV systems. So in that one, to classify PV systems condition into three categories. One is the healthy, another one is the shading fault, third one is the open circuit fault. So to classify these conditions, I am extracting the electrical parameters from these two curves. Those are the current and voltage characteristics. Another one is the power and voltage characteristics. So to classify the PV system conditions, I am developing with some models. Those are the logistic regression model, Navy bias, KNN algorithm. In these models, I am justifying to evaluate the on basis of accuracy, precision, recall, and effort score. So, in next one is the problem statement. In solar photovoltaic systems are increasingly developed for sustainable energy generation, but their performance is highly affected by the faults, such as partial shading, open circuit condition, and environmental disturbance. Due to this faults, reduce the power losses and the efficiency and decrease the reliability of the system. In already in the existing approaches, machine learning methods, there are often some complexity of the models and the limited data sets, and also lack of proper comparison between the different algorithms. So, in my paper, I am developing the robust machine learning based framework able to for accurately classifying PV system faults under nonlinear and noise conditions. So, from this one, I am developing the improve the accuracy and the reliability of the system. Next, fault classifications in PV systems. Fault classifications in PV, those are electrical faults, thermal faults, mechanical faults. In electrical faults, those are the issue the voltage, current, or power output. Thermal, in mechanical faults, physical damage of degradation and components. Next one is the fault detection in photovoltaic system for implementation. In PV model has modeled in MATLAB to see how different kinds of faults affected the model's output when it is tested under standard test condition. The characteristics given to this simulated model related to the real PV model as in this table. These values are the specifications of the PV model values. I'm developing the AI-driven fault detection process in PV systems like this way: data acquisition, data processing, feature extraction, model training, model development, fault detection, alert generation, and finally maintenance action. This is the fault detection process PV system by using the artificial. So methodology. In my work, a data-driven fault classification framework using machine learning techniques, I am using the current and voltage curves, power and voltage curves. In this one, I am using the models Navy bias and KNN and logistic regression. Next one is the results and discussion. From the first model, Navy bias model, in this model, I am taking a large and nonlinear and noise research synthetic data set. A Navy bias based multi-classification fault framework for PV models, you use nonlinear IV curve synthesis with random electrical changes to model 3 PV operating conditions. Those are healthy, partial shading, and open circuit faults. Each curve is made as 6 electrical features are taken. Those are the open circuit voltage, short circuit current, maximum power voltage, maximum current, and maximum power and fill factor. So you are using the tested 5-fold cross validated Navy bias classifier by taking the 4,500 samples. In 4,500 samples, I am tested in this one in 2,000 curves are healthy models and 1,500 samples are getting shading faults, 1,000 are getting open circuit conditions. So these are the performance matrix of the Navy bias. So in this Navy bias model, I am getting the overall accuracy 94.13. So in this one, I am getting the precision recall efforts. In the healthy condition 96.83, shading condition 91.32, 96. This is the IV curve in the Navy bias. This is the PV curve of the Navy bias. This is the confusion matrix. It is the group class versus predication class. So this is the analysis of PCA components in this Navy bias class. This is the distribution of power in training data. Next one is the KNN classifier model. In this model, to differentiate among healthy shaded or open circuit condition by analyzing the extracted electrical features. This model is based on the distance-based modeling is very good for finding fault because in the PV features. In this system, if K is equal to 7 is used, this value was chosen based on experience to balance bias and variance while keeping neighbor voting stable. In 5-fold cross validation is used to make sure that the KNN model performs well in general. This significations that the data set is divided into 5 equal sections. 4 of these sections are used to train the model, while the last part is used to test it. This is done for each of the 5 parts. If this is the performance of the KNN base. In this one, I am getting the 95.47 in overall accuracy. So compared with the Navy bias, I am getting the more accuracy in the KNN model. This is the IV curves in the KNN model. This is the PV curves of the KNN model. This is the confusion matrix in the KNN model. Here, more accurately is given the healthy conditions and shading condition and open circuit. Next one is the logistic regression. Compared with the previous 2 methods, I am getting the accuracy in this method 96.09%. Here, same. I am comparing the IV curves and the PV curves and the confusion matrix. Here, I am getting the more accurate results compared with the 2 previous methods. Those are the Navy bias and the KNN methods. Next, this is the finally of the accuracy comparison. In Navy bias, I am getting the accuracy 94.3. KNN 95.42, logistic regression I am getting 96. In this one, naive Bayes lowest performance. In this one, good but sensitive to noise. Shading misclassification is higher. In logistic regression, I am getting the strong baseline in the linear boundary also. So finally, I am getting the conclusion. In naive Bayes got the lowest accuracy, that is the 95.13, because it makes independent assumptions that don't work well with a couple of PV electrical features. In KNN, I am getting the accuracy 95.47%. So it happened placed a lot of noise in this method. So in logistic regression model, I am getting the 96.09%. In logistic regression, it can successfully give the better accuracy results in the IV and the PV features, even though it possesses the linear characteristic on its own. Next one is the logistic regression is the fast and reliable way to monitor of real-time PV systems. But KNN and naive Bayes are not reliable. Finally, feature scope in my work is the integration of the proposed framework with IoT-based real-time PV monitoring systems, as well as I apply the deep learning techniques, ANN and CNN, for improved the fault detection. ANN means artificial neural network, CNN means convolutional neural networks. So further expansion of detect additional faults such as degradation, hotspot, and inverter faults, implementation large-scale solar farms for scalability and automated monitoring. These are my references. Thank you.
Vivek sir, any questions?
Hello.
Sir.
Hello, I'm audible? Yes?
Yes, sir.
Yes, sir.
Yes. So, sir, very good presentation. Okay. Again, the question is the based on the scaling issue. So, are there any limitation in the scaling for this approach for large solar system?
Sir, no problem, sir. We are going to large industry also. You can use it, sir.
Okay. So,
You can use it.
okay. So, have you tried any ensemble approach to improve that fault detection? Because I have seen that you have used multiple algorithms, right?
Yes,
machine
sir,
learning algorithms. So have you tried any ensemble approach to improve the accuracy for that to improve the fault detection?
Is there, sir? In logistic regression, I have improved the accuracy, sir, 96.01, sir, compared with naive Bayes and KNN method, sir.
But these algorithms you use separately, right? Ensemble approach, that means not combining all these algorithms to boost the accuracy. Have you tried for that?
No, sir. Up to now, I'm tried separately, sir. Combined, not tried.
Okay. Yes, sir. Thank you very much. That's all from my side.
Ma'am, any
Yes,
questions?
No. I think we're out of time, 7 minutes. We still have one presentation, right? So let's move to that.
Okay, thank you, sir.
Thank you.
Now, next, I would like to call Utkarsh Patil to present the study on stimulation of secured agent-to-agent communication protocol with secure session key management with AI-based attack detection.
Yes, am I audible?
Yes, sir.
Yeah, let me share the screen. Yeah, is my screen visible?
Yes, sir.
Yeah, sure. Good afternoon, jury. I'm Utkarsh Patil from Vishwakarma Institute of Technology, pursuing my engineering in AI/ML, and presenting you our group project done with my co-authors, that is stimulation of secured agent-to-agent communication protocol with secured session key management with AI-based agent detection. Now we know that the era of agents have begin AI agents. So all major companies have started using AI agents to begin with their software problems and tasks. So these agents are not just capable of communicating with humans, but also communicating with their fellow AI agents. And for this, they required a secure, high level and communication protocol right? And one such protocol is developed by Google, that is agent to agent protocol. But because of its costliness and the high end design, which is it is not very useful for the low level companies or smaller individuals who are applying their own multi agent systems. So there we found the need of developing a more lightweight, secure, and a feasible protocol, a communication protocol for these AI agents. So currently, these communication of agents rely majorly on your API calling or your just third-party communication. Plus, these are not secured and tested. So, what problem that we have identified is that these communication protocols have are not secured, as they don't tolerate the attacks, communicational attacks such as man in the middle, flooding, etc. Also, the weak entry point for these communication protocols has led to its degradation. The only one layer authentication is done by these protocols, which is making them less secured and less smooth to travel the data. So the objective, what we have find is the objective of building this communication protocol is to form a strong foundation of the protocol, which we are trying to develop using web. We have tried to developing using WebSocket and Redis gateway. Then is what we have developed attack engine, that is to test our own protocol, and also a predictive and detection system, that is models to prevent those attacks as well. So all under one umbrella is what we have developed. Moving to our motivation, so the motivation is just the project is aiming to develop a secure, lightweight protocol for these multi-agents AI systems to able to communicate and just be easily feasible to low-level systems. So, what our major proposed solution is that we have done the application is done booking and travel agent system. So where we have created multiple agents for your hotel booking, your flight booking, your planning agent, etc., which is developed using LangChain and LangGraph based on Olama LLMs and context based. These are context based agents, and we have developed an agent card, a dynamic agent card for these agents. What these agent cards have is what these agents are capable of, what are their safe score, what communication they have had so far, etc. So this agent card is dynamically improving with the help of state function from LangChain, which is able to know which agent it is capable of communicating. So once these agent form a communication using WebSocket, what we have done, we have developed an attack engine. So this attack engine is basically a checkpoint added to the WebSocket gateway, where this will stimulate attacks such as MQTT, your MITM attacks, flooding, etc. And then on the other end of the WebSocket end, we have added an orchestration layer which has our ML model deployed. So by using this proposed solution, it will be more clear to you. So the XGBoost, we have created an XLNet model to predict the attack in advance, and plus an XGBoost attack to XGBoost model to detect the fake detection, fake links, or any fake identity of the agent. So yeah, this is all what the proposed solution we have. One of the implementation is the session key development. As soon as the agents build and communication line, the session key will be generated, which is capable of busting as soon as the attack is predicted and refreshing itself timely, so that no attack can be done. Which is the session key management system is developed using ECHD, which is a key management algorithm, right? So yeah, this is so far our proposed solution. One of the major implementation we have done, updation we have done in XLNet pipeline. So we had anomaly detection, such as your what exact messages these agents are sending to stimulate that, and the other is the attack that is happening through external agents. So we have developed a dual thread pipeline for that. So this dual thread pipeline is handling parallelly to both these attacks. so that the computational power and the size of this model is reduced so that we can deploy it on the protocol to make it more lightweight. Also, on the system architecture end, you can see the complete flow where we have also we have created agents having their own external tools, which is LangChain tool binding we have used for that. Yeah, so majorly our focus is on making it secure, making it portable. That is, it can be deployed to any LLMs or any agentic models deployed in any companies out there. And we have also tested our own models. So the attack engine has helped us test our own model, which is not done so far by any other uh, protocol developing community. So here you can see is the communication log. These are the communication log that we are uh, creating as at for every individual communication established, and this is helping our model train very continuously. So for that we are using online batch processing modeling for that, so that every session and every parameter is being evaluated regularly on every communication basis and giving you the prediction and detection of the attacks. So these are some of the models that we have used. So River Online Learning is the we have used for your timely training the model. Then your attack engine algorithms contain the following attacks. Then for fake detection, we have used XGBoot. We have created this external model because it was dependent on an external data set and not on the logs that we have mentioned here. So it was created separately. And these are some of the results. As you can these are the overview, sorry, the UI of the project, where here you can see the session. So this session, basically we have not kept it abstracted so that we can just show you how the session keys are forming and changing deliberately. So for here we have queried, and these links have been generated. Then further here you can here you can see the session established, and you can go back to the sessions which are already busted or an attacked. So we are storing those sessions into our Redis cache. Yeah, so these are some of the endpoints for attack. We have developed a complete flow for that. These are some of the results. So definitely we have able to achieve then higher accuracy when it is coming to prediction and detection because of the dual thread model, and we have used into it to classify different attacks. So far, we have got an average accuracy of above 90 for all the attacks that we have calculated through this project. And the baseline which we have taken was from the BERT model, which was already being developed for this security purpose. Further, talking about the major novelty of the project is we have created the protocol is created on a module based, so that every module can be shifted based on the nodes from the LangChain. Also, the XLNet model, we have applied dual threading into it and added a multi-level perceptron for distributing the class of the attack, which is making it more secure and stronger. Yeah, and also one of the important thing is that the tested testimony that we are able to test our application is some of the major novelty of our project. Talking about the future scope, what we are trying, these agentic cards need to be deployed on blockchain so that no third party or any individual can change those agentic cards manually. So deploying it on blockchain will be a great idea. Plus, we can integrate it with more higher security, such as deepfake or prompt injection, and that's yeah. So here I conclude with my presentation. Hope you like it. And these are some of the references that we have referred. And thank you. That is from my side.
Yes, Vivek sir, any questions for him?
Yes, quickly. Uh, Hello.
Yes, sir.
Yes, yes. As you have mentioned, that I hope I'm audible. Yes, Utkarsh. Yes,
Yes, sir.
Utkarsh.
Yes.
Yes. As you mentioned that you have.
Excuse me, sir. I'm
Yes,
so sorry to interrupt. Can I help with, because I am from his team, so can I help him with the question
yes,
answer?
yes, 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 100%.
Thank you so much,
Okay,
sir. Yes.
okay. So as you mentioned that line chain binding tool, right? That you
Yes.
use.
Yes.
Yes. So could you please explain how it integrates with your AI-based attack
Um,
detection framework?
Yes, sir. So basically, what we have done is we have used LangChain and combined all these tools with the prompts and whatever the orchestrator agent is getting from the client. And then we are integrating them using a gateway which is created by Redis and WebSocket protocol. So what it does that basically LangChain tool binding is basically when we have provided tools to those agents, so the prompt will get to the orchestrator agent and it will navigate us through these multiple agents. For our basically implementation, we have used travel tools. For example, we have used SERP API for web connection, web search connection. We have used APIs of GoIBibo and Make My Trip so that we can directly navigate users to those launch pads so they can directly book their tickets. And
And
so we have combined all these functionalities using LangChain, which is the tool binding. And the thing is, these agents are based on all these gateways. So if basically I just required a flight agent, so the orchestrator will only communicate to the flight agent and not go through all these five agents and directly create a communication session between three of us. So the user and the orchestrator will connect the user to the flight agent, and it will help them to navigate directly into the next page so that they can
Okay,
do the bookings and stuff. Yes.
and
okay,
also the tool binding you tool. So tool binding, as soon as the tool is, for example, your Google Maps tool, we have a link. So if the Google Map is giving some result, it is not directly going to the agent, but it is going through our secured gateway first. So that way, it is securing the outflow of the
okay,
third party result.
okay, okay.
Exactly.
And last question, as you created the communication logs that I have seen there, right? So you have created the communication log, right? Just to evaluate the each parameter for the prediction, right?
Yeah,
So
these are
could you
created
please,
dynamically for every communication.
totally understood, but could you please elaborate on which parameters were most critical for detecting the attacks? If you identified
Yes.
Yes, sir.
So
which,
so there was one session keys. So we are creating session keys, right? So so if the attack is happening, if the attack happens, there is major chances of this session key changing or getting stuck. So we have created threshold that this session key should change on a certain time. But if it doesn't change at that particular moment or the session key bursts, so these parameters are calculated on time logs. So we have used time logs for that. So this is one of the major plus the third party AI agent. So we have used a dynamic agent card, right? So dynamic agent card is given uh, uh, some unprotected score. So this score is been dynamically allocated and also stored on our logs. So if we find any unsecured logs into that data, that is basically targeting or flagging that it is a dark agent. So yeah.
okay, thank you.
Ma'am, any questions?
Do we have time or we need to wind up?
Ma'am, there is one more presenter who couldn't come when I called her name last. So,
Um, I just have a quick question about you guys. I know you guys talked about like different kinds of like cyber attacks, but attackers always invent new attacks. What if your system meets something different? Because you'll be training your system. I'm not from this field, so you have to educate me on this.
Yes, ma'am. So basically, what we are doing that we are creating a two-way accessing thing. So basically, what it will does that if a user is being logged in or basically user's identity is preserved, it has two kind of keys which use basically asymmetric encryption technique, which is the first of all, which is the session key through which it can handle the session. So basically, whenever we communicate in any LLM, for example, ChatGPT,
we create a session named with some title, right? So the session will be created in using an encryption key, and that encryption key will also contain a communication log key, which is basically the refresh token, which is created using the user's identity, right? So using that user's identity, we will create a refresh token which helps the agent to communicate with each other. And as soon as a person is trying to get into these endpoints, basically the orchestrator agent or these tools, which are the remote agents, like for example, the travel agent or the hotel booking agent. So at that moment, as soon as the attacker will get inside the endpoints, basically it can hinder the session key by using a 256-bit encryption technique, which can be anything, for example, secure shell or basically SHA or anything. So using that, it will get into a system, but the thing is, it will not have a logged in refresh token through which his refresh token can be created. So it will directly be detected that a person is getting into these endpoints. So the endpoint has been secured. And I think with that, there is no current situation through which a two-factor authentication with an encryption technique can be break down. So basically, it can enter the system, but as soon as it gets entered, the session key will be reverted because it does not have the refresh token. So this is the idea, and I don't think so. Currently, there is any system which can break this sort of security mechanism.
And also want to add that because we have developed this communication using different modules, so these individual modules are capable of changing dynamically. So for attack engine, so for in our prediction model, if a new attack is stimulated, we can add those small individual model to that existing system, and yeah, we can basically handle external attacks as well, which are not currently taken care by the system.
Fantastic. Okay. All right.
All right, thank you so much. Now, lastly, I would give a last call to Megha Poddar to present her study on an advanced graph neural network framework for modeling dynamic cyber network topologies and detecting anomalous behavioral patterns.
Yes, good afternoon, ma'am. Am I audible?
Yes, ma'am.
Yes, thank you so much. So my name is Megha Podar, Assistant Professor, Soundarya Institute of Management Science, Bangalore, Karnataka. So the research paper title is an advanced graphic neural network framework for modeling dynamic cyber network topologies and detecting anomalies in behavioral patterns. Cybersecurity is very important today. Networks are becoming complex and dynamic. Traditional methods cannot handle this. Handling this becomes a challenging thing. Networks change continuously because as it is dynamic. Attacks like intrusion, malware, DOS attacks might happen. So my research says that by using advanced techniques like GNNs can improve the detection and we can check out with the anomaly detections. So the problem statement says that when we are using the traditional method like SVM, the decision trees, these are bit ineffective and which leads to giving the false positives and cannot handle dynamic networks. So the objective of this paper is to evaluate different GNN models to improve the anomaly detection. When we improve the anomaly detection, the yield also will be high, accuracy will be more, false positives can be reduced, and computational efficiencies can be analyzed. So when we are using the methodology, we are converting a cybersecurity system into a graph wherein we are using three models over here, that is our CNN, GAN, and regraph. So when we use GNC, collects information from the neighbors and it creates certain nodes and represents. And when we use graph attention network, it gives an attention to the neighbors for the more intelligent, which is then GCN. And when we use GGraph, it uses wherein we can use the complex patterns, the structures can be analyzed, the networks can be analyzed, wherein it is bit advanced comparatively to the first and second. So So here what we are basically doing is we are converting cybersecurity into a graph wherein nodes can be considered as devices, users, and services. Edges can be called as interactions, and we enrich with a graph wherein we take the network data, we convert it into a graph conversion using the GNN models, then we train and test them, and finally, when we get output, it would be in the anomaly way wherein we have detected the anomaly detection. Yes, so these are certain way through which we can implement that. So when we have compared the traditional method versus the proposed method, we have used certain traditional method such as logistic regression SVM decision trees, wherein these comes under traditional ML, and the accuracy which we had got using certain data set was 72.5 to 70 ranges. But when we have used this GCN, GAT, and regraph GN, the accuracy rate is also increased. So the matrix which we have used here is accuracy, precision, recall, F1 score, AUC, ROC. So by doing this, more of the efficient way or more accurate way for the proposed model can be achieved. So advantages is highly accuracy in anomaly detection. It could handle more complex structure. False positive can be reduced. And when we talk about disadvantages, when we talk about regraphing, it requires more computational costs, more longer training time might be required, and complex implementation of model is also required. Yes, so when again it was compared with the traditional versus our proposed, so this was the accuracy which is being shown in the graph. So the future enhancement for this would be improve the scalability, because as the complexity increases, even the networks also is dynamic. It keeps on changing. We need to get the robustness in this. We have to develop a hybrid models wherein we can check with the behavioral pattern structure and which we could implement in the real world cybersecurity environments. Yes, the conclusion, what I want to conclude by this is this study shows that it is more significant when it is compared with the traditional way of doing this one. But when we take our proposed model GCN, GAT, and GGraph, it is more reliable to detect the anomalies, and we could give the more efficient way or more accurate way for the networks. So these are certain references, and thank you so much for giving me this opportunity. Thank you.
Yes, thank you. Vivek sir, any questions for her?
Yes. Hello, Megha ma'am.
Hello, sir,
This
sir,
is,
sir. Yes, sir.
yes. Nice presentation. I have only one question, that you have compared that GC and GAT and regraph JN with the traditional model like logistic regression, SVM, and decision tree, right? So
Yes, sir.
have
Yes, sir.
have you tried the same data set to other model as well, like the
Sir,
nearby?
only
ANS?
no, sir. Only few models I had taken. That is only this three models, wherein I took the traditional three ways to compare this with certain data sets. So the comparison is only between these three. I have not tried for the other set of
Right.
models, sir.
Yes. Why I'm asking, because
Yes,
the accuracy matters again based on the data set, right? If
yes,
suppose
sir.
we have
Yes,
the independent feature, then we generally prefer the naive bias, then
yes,
distance
sir.
based model, then probability based model, right? So
Yes, sir.
based on that, there may be chance of improve the accuracy, right?
Yes,
So
sir. Yes.
uh, my suggestion is to compare with the
Mhm.
other model as well. Okay.
Yes, sir.
And
Sure.
yes. And one more thing, have you tried the ensemble approach for the proposed algorithm which you have mentioned, GCN, GAT, and regraph? Have you used
Sir,
any ensemble approach? Yes.
no, sir. It is just in a comparative study, sir. Ensemble approaches will have multiple models to improve the performance. As I have taken only few focused
Comparison.
model, yes, few
Okay. You,
focused models. I have not.
okay.
Yes, I have not taken.
Understood. Your focus is
Yes,
on only comparison, right? Okay.
yes, yes.
Yes. Yeah, okay. Thank you. That's all from my side.
Uh,
Thank you.
Thank you so much. Thank you.
Yes, thank you. Ashavari ma'am, any questions?
Just a last question, just to keep situate this in real life, Megha. Wonderful presentation. Who actually uses these antennas? Like, what problem does it really solve for these organizations or individuals?
Ma'am, when we talk about real-time applications, this in the real time when we have cyber security system, networks are really it is not represented as we have thought in graph or the nodes or whatever. It is used in the real-time application wherein certain what we can say, the behavior might change. Suppose I have a source and a destination, I have to send some messages, correct? But due to abnormal behavior, the node might change there, correct? So we want a reliable communication that has to happen. Yes, we don't want any unusual patterns that should occur. Yes, when we use these kind of models, we can detect the unusual patterns, or sometimes we can also detect the cyber frauds or attacks or any problems related to the network, wherein they can analyze this. Yes, like it is like a predictive maintenance wherein we can analyze before something goes wrong. We can use this, we can adopt this, and we can repair that so that no further anomalies should be occurred in any sort of the real-time
Okay.
application.
And if you were to tell a lay person which industry uses this, what would it be?
Uh, so many of the industry would be using this because when it comes for your Cisco, when they're really into VMware, wherein they're using much of networks, they have to use all these approaches because their network should be more secured. Yes, they should be more what is confidential. They cannot just simply use a normal way of detecting this. They have to use many computational models which will help this because they have to scale, they have to use this in real times, wherein they have to use all this graphic neural networks for the better performance. Yes, because their data is very confidential for
So you're
real time
looking at
application. Yes.
so mostly tech conglomerates and things of that
Yes,
sort, right?
yes, yes, yes.
Fantastic. Okay. All right. You answered my question.
Thank you.
Yeah.
All right, thank you, Megha, for your presentation.
Yes, thank you.
So with this, we are done with all the presentations. I sincerely thank our authors for their excellent presentations and contribution in the session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Hence, kindly cooperate with the team of ICTIS 2026. Next, I would like to thank our session chair, Dr. Ashavari Das, for chairing this session. I'm sharing a token of appreciation on behalf of team. Thank you so much, ma'am, and please share a concluding remark for our presenters.
Thank you so much, ICTI's team and Dhimai for moderating this. You did a fantastic job. And thank you, Dr. Vivek, as well. So I just wanted to offer a few thoughts about what I heard. Again, as I said, I come from a social science perspective, but I look at other dynamics, and I'm glad to see that really truly interdisciplinary research can happen when there is a will. And we saw multiple topics today. We saw cryptography, cybersecurity. We saw medical things with the spinal cord, for example, topic. I really heard the researchers looking at real life problems. So that was that was a great experience. And I saw that the technical sophistication was really good. So, I really, really thank you for all your vulnerability and the rigor that you've put in, the way you answered questions. Fantastic. And I think there's a lot of scope in your research. And our fields are getting more and more interdisciplinary, and we're doing really well with that. So use today's questions that were asked by Dr. Vivek and myself as a place where you can revise and reawaken and deepen, right? Don't take it as any kind of judgment. Fuel it in the right way. And I also invite the audience to kind of look at these papers in the most curious and generous way, right? So I always say that we have to ask the hardest questions, but in the right spirit of like collective learning. So again, I'm very passionate about research, and we care enough about problems to give it time. We care enough about knowledge to kind of put in the rigor and put in the process. So thank you so much for making me part of this. I'm glad that I was part of this. So all the best to all the researchers.
Yes, thank you so much, ma'am. And I would also like to thank Dr. Vivek Patil for his presence as our session chair. Thank you, sir, on behalf of the whole team. And I request you to share any concluding remarks.
Yes. I hope I am audible. Yes.
Yes, sir.
Yes. So first of all, thank you everyone, right, for your excellent presentation and insightful discussion, right? Uh, yeah, we saw a wide range of innovative work today, right? From as I observed that from AI-based fault detection in solar system, right? Again, advanced machine learning and deep learning models are there. Secure communication protocol, image in painting, right? Sentiment analysis, real-time gesture control system, and location-based platform. So, as you said, that wide range of innovative work, right? So it was inspiring to see that the depth of the research, the practical application that you have mentioned, right, and the technical expertise that you have shared during this session, right? I appreciate the effort of all the presenters in addressing all these important challenges, right, in their respective fields. Okay, and also I would like to also extend my sincere thanks to the my co-session chair, Dr. Ashavari Das Madam, for her support and collaboration in making this session like smooth and productive, right? I also encourage all the participants to continue exploring these ideas, collaborate across the domain, right, and apply this solution to real world problems. Once again, thank you all the presenters and attendees for making this session very engaging and productive. Thank you very much.
Yes, thank you very much, sir. Now, lastly, before we conclude this session, I kindly request you all to turn on your cameras for a quick snapshot of this virtual conference.
Deepai, please do share the snapshot as well, okay?
Yes, sure, ma'am. All right, thank you, everyone. Have a great day ahead.
Thank you.
Thank you.